Okay, let's solve these equations in MATLAB. Now before we do the matrix calculation, let's draw a picture and make sure we know what the solution looks like. You can see in the command history over here that I've done some prep work. So what I decided to do was make a list of x's from 2 to 4. And I'll go ahead and let it echo to the screen there so you can see the list of numbers. And I said y1 is my first equation. I don't need to see that. And y2 is the second equation. So I have everything stored, and since these are lists, I can use the plot command. So plot. Now the nice part about plot is you can actually plot more than one curve or more than one equation in the same command. You can see it just popped up here. See where it says y1 or x1, y1 all the way up to xn, yn? I can just stack as many of those as I want in here. So I'm going to say x, comma y1, comma x, comma y2. There. Now, if I want to spice it up a little bit and change the colors, I can make the first one blue. That's what the B means. You know what, if I make the second one red. There we go, and I can make them dotted line, dashed lines. I can do all kinds of stuff here. Hit return. Grid would be good. There we go, and I'll bring this down where you can see it. And when I looked at the calculation on the board, it looked like the answer was x equal 2, y equals 2. Well, there it is. Now, one thing about plotting straight lines like this, when I made that x vector, I put a bunch of points in it. You can see over there. In fact, if I go and right-click on that and turn markers on, you can see where the markers are. I don't need that many. If it's just a straight line, I really just need the two endpoints. MATLAB, when it draws the lines between markers, draws straight lines. Well, this is a straight line. My x vector could have consisted of -2 and 4. I could have just skipped all that stuff in the middle, and this would still work. So keep that in mind. You don't always need very many x points. Okay, now we know what it looks like. Let's see what it's going to look like if we clear this out, actually. Let's write this out in matrix form. Now you saw on the board that A was a matrix. I think I used capital A on the board. So I'm going to type in the left square bracket. That says what comes left next is going to be either a matrix or a vector. And so I want to type in the first row. I'm going to type in 2 space -1. Now that space says these are separate elements on the same row. Now there's two ways to do this. I can also use a comma if I want. I'm going to go ahead and just leave a space here. When I want the next row, I type in a semicolon. Now why a semicolon? I don't know. The person who programmed this thought that was a good idea. You have to use something on the keyboard. That's as good as anything. Hit return, and now A is a matrix, just like the one I wrote on the board. Well, let's just make B. Again, open up that left square brace there, left square bracket, to tell it that what's coming next is going to be either a matrix or a vector. And to MATLAB, a vector is just a matrix with either one row or one column. And this is going to be 2 and then semicolon 4. Okay, let's just let that go to the screen. Okay, that looks good. Now, all I have to do is type in INV times B, and there it is, 2 and 2. X equals 2, y equals 2. Now because it's MATLAB, there's more than one way to do everything. And so there's more than one way to invert a matrix. You just saw one of them. There's another notation that's this. That is very specifically says inverse of A times B. This operation is used so often, it made sense to have kind of a shortcut. So if I hit that, there we go again. 2 and 2. If I want to be more formal about it, I can type it in that way. I will also get the same answer. So 3 different ways to invert a matrix. Now let me leave you with one more thought. It's easy to divide one number by another one, but there's one case in which that operation isn't defined. If I try to divide any number by 0, the result is undefined. And along those lines, there are matrices that act like dividing by 0. And I'm going to bring A back up again. There we go. And I'm going to change it. And so there it is. And rather than trying to multiply the inverse of A times B, I'm just going to ask it for the inverse of A and see what it does. Ah, singular to working precision. And look at that, the answer INF means infinite. What that means is I just did the matrix equivalent of trying to divide by 0. So not every matrix has an inverse, and for those that are non-invertible, or what's called singular, that's the equivalent of trying to divide by 0. We'll talk about this more in a following lesson. So there you go. Now you know how to find solutions to linear equations, at least in a simple way, and you know how to solve those problems in MATLAB. I hope this helps, and we'll talk to you next time.